Welcome back to our channel. My name is Teacher Smith and today we are going to understand a very important principle on counting. Now, to understand the principle well, I have taken a question from year 2024 SASMO, question number 23. So without wasting any more time, let's get started. So here the question says, how many different 3-digit odd numbers can be formed using an odd number of matchsticks in total? Let's try to understand the question. Here the question says we need to form 3-digit number. The question is asking how many 3-digit odd numbers. So here I need to form 3-digit odd numbers, making sure the number is odd, but from the matchsticks that are present here. And after forming this 3-digit odd numbers from the matchstick, I have to make sure the sum of the matchsticks is nothing but odd. That is what the other part is asking. So here what the question is asking is, first we have to form 3-digit odd numbers. And then we have to also check the total number of matchsticks should be odd also. So actually the question is asking us two of the following part. First, where we have to find out how many 3-digit odd numbers are there, and secondly it's asking us to make sure the total number of matchsticks are odd. So to understand this question, first we need to understand how we can find out the number of odd numbers that we can get from the digits. So to understand this, let's say I'll take an example. So here we have an example. Let's say if I have some digits like 2, 3, 5, 6 and 8. And we need to find out how many 2-digit odd numbers we can form from these digits. Now, I need to form 2-digit odd number. Now, for any number, how we can ensure a number is even or odd? What do we check? Yes, we check the last digit. If the last digit is odd, we can say the number is odd. If the last digit is even, we can say the number is even. So here, we have to find odd numbers. So here, the last digit has to be odd. Now, out of all the digits that are present, which digits I can put at the last place so that the number is odd? Yes, here we have two of the following choices. 3 can also be at last place and then 5 can also be at the last place. So I have two choices, 3 and 5. So if 3 and 5 is here, which digit I can put at the very first place? That is at this position. Yes, we can first try it with 2. So I can place 2 with 3 and I can also place 2 with 5, giving us two numbers which are odd. Now, is this the only possibility? Of course not. Here, if I keep the digits same, that is 3 and 5, the first digit I can interchange, making the two numbers, that is 5, 3 and 3, 5. Is this the only number? No, the last digit are the same that we know, that is 3 and 5. We can pair it with this, our 6 that is present. So the digit becomes 6, 3, that is 63 and then 65. Is that all? No, this last digit that is pending, that is 8. I can pair it with 3 and 5, giving us 83 and 85. So, how many 2-digit odd numbers did we form? Yes, if we count the total number of numbers, this is simply 8 numbers. So, what we can understand, in order to find out the numbers that are present to be odd, we need to pay attention to the last digit that is present. But, imagine if there's a lot of digits present and also there's lot of places. Are we going to list down all the numbers that are present? Might take time, right? So let's see what's the quickest way to which I can get the answer 8 directly. So the principle remains the same. I have to find 2-digit odd numbers. So the 2 digits that we have. Now, how I can ensure the number is odd? Yes, the last digit has to be odd. So here the last place should be an odd digit. So out of all the numbers, all the digits that I have, which digit I can put? Yes, we just saw it's 3 or 5. So how many digit options do I have? Yes, there are just two options, that is either 3 or 5. So at the end, there's just 2. Now, at the very first place, how many options do I have? In total, I had 5 digits. And in the last place, we are going to put 1 digit. So how many digits will be left now? Yes, just 4 of them. So here, I can place this 4 digits here. Now, the question arises, which sign to put in the middle? Now, most of you will say multiply because here it's 8 present. No, but there's another way in which we can ensure. Here, what we can check is, there are 2 of the following options. This means 3 and 5. These are the 2 options. And each of the option has how many combinations? Yes, we can see each of them has 4. So, one of the option got 4. 2 will have? Yes, 2 times 4. And that's the reason why there is a multiplication sign. And then the answer is 8. So, what we can understand from this part is, if we want to check if a number is odd or even, we just have to pay attention on the last digit. The second thing that we can understand is, after pointing out all the number of choices, which sign do we put in counting principle? Yes, we put multiplication sign. So these are the 2 things that we can understand in order to find out how many odd numbers we can form. So moving back to our question. Our question also is same. Here, but it's asking 3-digit odd numbers. So let's say this is the first part where we'll focus on to form 3-digit odd numbers. Now, if there is this 3 digits present, how I can ensure it's odd or even? Yes, we just saw the last digit has to be an odd digit. Now here, the matchsticks that I have starts from 0 all the way to 9. So, how many digits I can put here in order to make sure it's odd digit? Yes, we can put 1, then 3. We can put also 5, then 7 and then 9. If I put any of the digits present, we can ensure that the number is odd. So here, how many options do I have? Yes, we just have 5 of the options. Now, if 5 of the options are present here, how many digits I can place at the very first place? Yes, we have digits from 0 to 9. So, does that mean I can place all the 10 digits here at this position? Can I place all the digits from 0 to 9? Of course not. We can't place 0 in here. Because here if I place 0, it becomes 2-digit number, which is not possible. So here, apart from 0, I can start from 1 to 9. So how many digits do I have? I have 9 of the following digits. So this is what we can understand. Now we have to make sure that the total number of matchsticks that are present is nothing but odd. So this part has to be odd. But we can pay attention here for now. The number of matchsticks that I used here, the digits 1, 3, 5, 7, 9. You can pay attention on any of the digits. Let's say 1 and 3 here. The number of matchsticks that I used are not odd. Some of them are even also. So if some are even, some are odd that are in this 5 digits. Also in this digits from 1 to 9. There are matchsticks that some are even, some are odd. So, how I can ensure that the total number is odd? So, that brings us to the second part of the question. So, first part is pretty simple where we can find out the possibilities of this 9 and 5. But for the second part, let's try to understand this step by step. So, the second part we need to check if the total number of matchsticks is odd or not. Now, for this, first we need to understand in this digits from 0 to 9. There are how many of the digits that are present are even, how many of the digits are odd. So let me highlight it here. Even number of matchsticks and odd number of matchsticks. So here let's start from the very first digit, that is 0 here. Let's just see how many matchsticks are used to make this 0. Let's count. 1, 2, 3, 4, 5 and 6. This means 6 matchsticks are used to make a 0. So 6, is it an even number matchstick or odd? Yes, it's an even number matchstick. So I'll place 0 at even number. Now let's see the next digit, that is 1. Here there are 2 of the matchsticks used for 1. So 2 is an even number. I'll place 1 at the even section. Now let's move to the next digit, that is 2. Let's count. 1, 2, 3, 4 and 5. So 5 is an odd number. I'll place it on the odd sections. 2 belongs at odd. Let's move on to the next. 3. 1, 2, 3, 4 and 5. So it's an odd number matchstick. Let's move to 4. 1, 2, 3, 4. 4 has 4 number of matchstick. What a coincidence. Let's place it at the even section. Then let's count the next one. 1, 2, 3, 4, 5. Oh, 5 is just an odd number. So let's place 5 at odd number sticks. Then let's count for 6. 1, 2, 3, 4, 5 and 6. So even number matchstick. 1, 2 and 3. Odd number matchstick. 1, 2, 3, 4, 5, 6, 7. Oh, it's again an odd number matchstick. Now let's try for 9. Here 1, 2, 3, 4, 5 and 6. So even number matchstick. So what I can understand from here, the even number of matchstick that are present is 0, 1, 4, 6, 9 and odd number is 2, 3, 5, 7 and 8. Now regarding the digits that are present at this section, that is the odd digits. These odd digits are 1, 3, 5, 7 and 9. So we can understand some are even and some are odd. Also in these digits from 1 to 9, there are digits that has both even and odd. So how I can ensure that the total is odd? So let's just check. Here let's say the last digit is odd number matchstick. The number is odd. Here and let's say here the first number is even that is present. So how I can ensure that the sum of this is nothing but an odd number of matchstick? How I can be assured? Yes, we can only be assured if the last place that is present here is nothing but an even number matchstick. If this is an even number matchstick, then I can assure it's an odd number matchstick. So for even here, we can understand there are how many possibilities do I have? Here, I have 5 of the following possibilities for even. So let me highlight it for you. This is just 5. Now, this is simply odd. And let's say instead of this even, I have odd number of matchstick. So how I can ensure that the sum of this is nothing but odd number matchstick? Which type of matchstick should be present here? Yes, the only type that should be present here is odd number matchstick. Now, even if it's odd number matchstick, how many options do I have to put this here? Again, if we count, it's nothing but 5 that is present. So even if it's odd, even if it's even, here the number that is present is nothing but just 5. But at the last place that is 5, not only there's odd digits that are present, here there are some of the digits that are even also. So here if I have an even number of matchstick and also let's say at the start I have even number matchstick, how I can ensure that the total number of matchstick is odd? Which type of matchstick should be present here? Yes, there are already 2 evens present. To make it odd, this should be an odd number matchstick. And if it is odd, how many options do I have? Yes, we just have 5 of the following choices. Is this the only condition? No, if this is even, then apart from this even, it can also be odd number matchstick. And if it is odd, the last place, how I can ensure that the sum should be an odd number matchstick? How I can be assured? Yes, for this here, I have already 1 even present. If I add 1 more even, then I can ensure that it's an odd number matchstick. And for even, how many choices do I have? Yes, it's just 5. So what we can understand from this part, just observe. No matter what, which digit is present here, even or odd. No matter what digit is present here, even or odd. Here we can change the number of possibility and always what is the number that we can observe? Yes, it's always 5 that is here. So let me highlight it for you. This is simply every time it's going to be 5. So the only digit that I can place here is 5. So now we got the choices for all the places. Now which sign should we put in the middle to get the answer? Yes, the only sign that we have to put is multiplication. And if I multiply this, we get the answer that is 225 ways. That is numbers that are present. So what we can understand from this part? Here from the second part we can understand no matter which digit it's asking. It was asking us odd number matchstick. No matter what it's asking. Just the last step of our calculation. That is the middle one. The middle one determined if the sum is odd or even. This is the second thing that we can understand from this question. The first was regarding counting principle and the second one was regarding the number. Even if we need odd or even number, the last step will determine if the number is going to be even or odd. So let's summarize everything. To make sum of numbers to be even or odd, which step determines? Yes, the last step determines. This is what we can understand. Now, if you have understood the question well, here there's a good news for you. We are conducting a mock test in our learning center. Here the date is mentioned on the poster, that is on 18th of March from 3 to 4:30 p.m. Here, make sure you come to our center to give this mock test. If you want to sign up for this class, there is a QR code. You can download the app and register for yourself. But if you have any doubts while registering or while solving question, you can scan the QR code above. That is P2, P4 study group. And I'll help you solve any question. For now, this is Teacher Smith signing off right now, but I'll see you in the next video.